Hi, everyone. Hello, good evening.
Hello, good evening, everyone. Dr. Umar, Dr. Chagan. Very good evening.
Good evening,
Good evening, sir. I will give a call to Santosh. I mean, I will be away.
Yes, no problem. Like we are waiting for the participants. Should start, I think, after 10 minutes. So it's okay. Bit late. So I'm also recording this meeting. I'm not every time sure that I got the support from Bangalore section. So I'll store in my desktop. I will upload and share to the coordinator once it is uploaded in the G Drive.
Yeah, it's better, sir.
Okay. Yeah. Are you able to see it is recorded? Someone can confirm me. It is somewhere it is showing recording is going on.
No.
Okay, it is
No,
my
sir,
system.
not
It
yet.
is recording. Are you able to record, Dr. Uma, if you like to try?
No, event is recording, it is showing.
Yes, that's what I want to see. Yes.
Yeah, that right, top right corner, that red button, it is highlighted with recording showing.
Yeah, thank
Recording
you.
in progress.
Yeah, event record is in progress. Yes.
Professor Uma, you verified the feedback link for this. If you like to share, you can share me.
Just a ma'am shared with me. I just forward you.
Okay. I mean, just it should be just checked at least once.
Yes, sir. We have
Okay.
checked it. It is working.
Okay, done. No problem, madam. No problem. Thank you.
Santosh is joining, sir.
Yeah, sure. Once he join, I'll make him presenter. Dr. Jagan, let me know once Mr. Santosh join so that
Yeah,
I
yeah,
can
yeah.
make him as a presenter.
Sure, 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 sure. Even
Okay,
I'm
next.
also waiting for it is downloading, I think, for him the WebEx link. That's what he mentioned. Amber sir, he is telling that it is taking to the WebEx link. Any username password he has to enter, something like that, or because for me it downloaded temporary application, it automatically.
He can directly click to the URL and the password. I think ITS 2021. The
One second,
same
one second.
WhatsApp information you can share to
Yeah, same
list.
thing. That is what I have shared. Just
ITS 2021.
So even the other way is he's having the ID. I mean the meeting ID plus the password. There are the two ways, and either way he can use to
okay, okay.
connect to the meeting.
That WhatsApp, this one it is there. Okay, the link
Yes.
is there, but it downloaded temporary application and I could able to download. I mean login, sir. But
He can. No need
but
to install the WebEx using URL only.
can
He
you can
can.
you can you share me in WhatsApp username, password, the meeting ID and password, sir?
Okay, I'll
Can
reshare you. Just a second.
it didn't took that much struggle for me. I think he is struggling. Okay. Event number. Okay, event number it is there. Okay, okay. Santosh. Okay, okay. That is the event. I have shared, sir. ITS 2021. Event
Yes,
number 13019543228. Okay. I
that's
just
correct.
shared to him.
Dr. Jagan, will he?
Yeah, I was in touch with him. He is
I think he
traveling.
joined. Santosh Kumar, I let him.
Yes, Santosh Kumar, if he joined, then you can make him.
Yes. Okay, fine.
Yeah.
Uh,
Hi, Santosh. Can you please acknowledge?
Hi, good morning, good evening, Jagan sir.
Yeah.
Sorry
No
for
problem.
joining late. My laptop had some issues, so yeah.
No problem, sir. No problem, sir. Maybe quickly, we can, Amber sir, can you please start the.
I request Dr. Sujata Patil to please start this meeting. Thank you.
Yes, sir. Shall we start, sir?
Yes.
I think we should start.
A very good evening to all the dignitaries, all the IEEE representatives, EXICOM members of various regions, and all the branch counselors, student volunteers. So I, Dr. Sujata N. Patil, EXICOM member, IEEE ITS chapter, HOD of Electrical and Electronics Engineering, KLE Dr. MSS CET Belgavi, welcome you all to the international webinar on Digital Twin Representing Physical World in Virtual Space, organized by IEEE Information Theory Society Bangalore chapter in association with IEEE Bangalore section and IEEE Mysore subsection. So let me start this event by briefing about the IEEE. The Institute of Electrical and Electronics Engineers is world's largest technical professional organization dedicated to advancing technology for the benefit of humanity. IEEE and its members inspire the global community to innovate for better tomorrow through highly cited publications, conferences, technology standards, professional educational activities. IEEE is a trusted voice for engineering, computing, and technology information around the globe. IEEE Information Theory Society members enable an individual to stay updated within the chosen technology and ensures one in touch with the peers. IEEE Information Theory is a leading technical society that focuses on processing, transmission, storage, and use of information as well as the foundation in the communication process. So with this brief introduction about the IEEE and IEEE ITS chapter, now I request the IEEE Bangalore section secretary, Dr. Amber, to tell brief report about the IEEE ITS activities.
Thank you, Dr. Sujata, for giving me a chance to brief about the Information Theory Society. So myself, Dr. Amber Bajpai, I am the secretary in Information Theory Society chapter here in IEEE Bangalore section. We opened ITS chapter in 19th January 2021. Inaugurated by IEEE President of ITS, Dr. VU, along with the presence of the chair, Dr. Bindu Vadhava, and past chair, Puneet Mishra, and with our chair, Dr. Parmeshachari. And since then, we continuously attracting many students, many professionals from academia as well as in the industry. We have a strong presence as of now in the short span of time in IEEE Bangalore section, with proudly can say 250 members in IEEE Bangalore section ITS chapter. And this is our 19th webinar, international webinar, and most of our event is conducted by extremely experts person from the related field. So we also have the presence in more than 10 student chapters of ITS around the Bangalore section. We continuously increasing. So I request all of you, if you are not a part of Information Theory Society chapter, please be part of this to be learn various experience from the experts and knowledge sharing experience. With this, thank you, Dr. Sujata, to giving me time for just briefing of the Information Theory Society chapter. Over to you, Professor.
Thank you, Dr. Amber. Briefing about the ITS activities. Now, may I request Dr. Jagannathan to introduce today's speaker, Mr. Santosh Kumar M, Technical Director, WS at Kids. Dr. Jagan, over to you.
Thank you, madam. So I'm very much happy to introduce Santosh Kumar. It is the second session from him on this forum, basically. So Mr. Santosh Kumar has around 20 years of experience in software development, focusing on next generation technologies. His current role as a technical director, WS Atkin. He is currently focused on incubating use cases in AEC industry using blockchain, IoT, AI technologies. Some of the areas he is currently working on: automation of interdisciplinary checks for 3D using blockchain, collaborative design using augmented reality application, next generation self-service driven analytics platform. Mr. Santosh Kumar is a IEM certified asset management professional and has filed patents in the area of targeted and placements and dynamic personal network manager. His research also includes study the dynamic network relationship between multi-networks and enable enhanced innovation. He has been a speaker for different national and international forums such as ITU World, Dubai, National Association Broadcasting, Las Vegas, to name few. And this is the second session. Previously, he talked about a session he has given around a month back on blockchain, and it was so successful. I hope this is going to be very well received by our audience. With that introduction, handing over to you, madam.
Thank you, sir. Now we are very eager to listen to Mr. Santosh Kumar, sir, on digital twin representing physical world in virtual space. So I request Santosh Kumar, sir, to take over the session.
Thank you, madam. Thank you for giving me this opportunity, and apologize for joining late. I'm going to log in. Without wasting much time, let me just give a quick introduction. So basically today what I will do is I'll just talk about what digital twin is, how it evolved, where it started, and where it is going today. And I will also share few use cases which we have implemented in our organizations. If any questions are there, you can interrupt me, or you can put in the chat message, and we can respond at the end of this presentation. Again, I'm having some issues with my slideshow mode, so I'll be presenting it. So hope you are able to view this slide, and you can read the slides. So
Yes.
okay, thank you. So basically, just to give an introduction, the digital twin, the terminology was introduced by Dr. Michael Grives from University of Michigan, I think as part of his course in product lifecycle management. I think the product lifecycle management is all about manufacturing of products, right from the design stage to actual factory uh, manufacturers consumers, and then trashing safely trashing the
Santosh, sir,
equipment.
make sure that you have connectivity is good. Sometimes in between it is not audible, kind of thing in between.
Yes, it
Okay.
is breaking.
Is it better?
Sir, you continue, sir.
Okay, just let me know if you're still facing that issue. Otherwise, I'll change my network. Okay, so as I said, the concept of PLM, or product lifecycle management, starts right from the design, the drawing boards, to the decommissioning, recycling and decommissioning of a particular product. That's how the digital twin started. But in the early days or initial days, if you look at the first uh, decade of digital twin, it was prominently applicable in the design stage, because most of the time people earlier were doing their designs or drawings in pen and paper, in those drawing boards, etc. They tried to then use the tools like the CAD CAM tools for actually doing some developments, etc. And I think that's when the design optimization or the simulation saying it, what is the maximum parameter, what are the constraints, etc. So people started looking at different options, looking at different scenario planning, the threshold identification, saying that, okay, if I increase this threshold, what will be the impact? What will be the impact on the life of that particular product, or what will be the impact of the breakage of components within that product, etc. So that's when the simulations, the digital twin use in the simulation world started. And I think with the evolution of 3D actually evaluate and see if we can miniaturize and what will be the impact of using different materials, etc. And then slowly in the last couple of years, I think I would say about 5, 6 years, what with the evolution of 4G, 5G networks, what has happened is they're able to connect directly and get the feedback. So now what has happened is the connectivity between the design phase and actual implementation or operations of the product started integrating, or the distance started reducing or narrowing down. And now what happens is you get the
Hello, Santosh sir. Santosh?
yes, yes, Jagan sir.
Yeah, you are not audible, sir. Quite often it is happening. I think
Okay,
you.
just give me 1 minute, Jagan
Yeah,
sir.
yeah,
I'll just
yeah,
switch my network. Yeah.
yeah. Please.
Is this better, Jagan sir?
Yes, sir. Yes, sir. Continue, sir.
Okay, let me know if you're not able to hear me. So as I said, in the last 3 years, what has happened is with the advent of computers, analytics, AI, etc. coming in, analytics and immersive experience feedback loop has started increasing, where the machines are now slowly taking over and making some informed decisions, basically reacting so that the feedback loop goes back to the actual operations of the product. So that's the journey or evolution of where the digital twin is going on. While the evolution has happened, the definition of digital twin also has been evolving. I think there are multiple players in the ecosystem. You will hear different definitions. For our purpose and for this today's presentation, I'll basically, it says that digital twin is a digital representation of the physical world or physical asset or physical system for a given use case. Because if you're talking about manufacturing, then that will be a particular use case. If you're saying that you want to optimize, so it could be a process related use case. If you're looking at predictions, then the prediction use case would be different. So basically what we are saying is the entire system, the models will talk about what the system means and what a digital twin constitutes. So basically it is a digital representation of the physical world for a given use case, because different players will have different use cases. That's the definition we will follow. So as I said, what it means for us is digital model. Digital model means rules, behaviors, data characteristics, attributes, etc. Right? So that's what when I say a digital model of a physical asset, right? So basically, I can create a digital model and I can use it multiple times, right? Because I might have the same pumping machine. Let's say I'm doing a digital twin for a pumping machine. I can have 3 pumps installed. So, and the digital model might be the same, right? I might have bought the pump from one particular vendor, but then the scenarios, right? One pump might be pumping, say 200 cubic meters of water. Another pump might be handling water sewages, etc. So the characteristics would be different. So that's what we are saying, that in a twin, what we do is we take the digital model and create an instance of that digital model. And then what we do is we capture the different inputs or parameters associated, like I said, attributes associated with that. We understand what are the different behavioral models for that. Each of these, for the same pump, the use cases might be different. So the behavioral model or expectations, the constraints, the thresholds, etc., might be different. So that's what you give when you instantiate, you specify those characteristics, and then you continuously proactively keep monitoring it, use different algorithms. I'll talk about the algorithm ecosystems to identify and predict the failures or basically the functioning, the operations of that particular product, right? So again, it just doesn't mean the operational aspects. It could also mean the process aspects. It could mean the actual physical characteristics. It could also mean the environmental characteristics. So basically your attributes is just not related to that particular product. We are looking at it as a system as a whole, right? It is not restricted just to one particular equipment or one particular component within that equipment, right? Digital twin has been started off in the manufacturing world, like I mentioned earlier, but I think today it has found its use cases in multiple different scenarios. Like in some of the examples or where we are currently applying it is basically in nuclear plant, because it's one of the sensitive hazardous area. So digital twin has found adoptions for different use cases within the nuclear energy space. The other big use cases is in the constructions. I think construction is the late entrant. I think in the last 2 years, construction industry has actively started adopting the digital twin. They're still in the very early stages of integrating the design phase and the actual implementation phase. But prominently with the operate and maintain part of it, we are seeing people aggressively adopting, with the pandemic also forcing people to use a digital twin to manage, monitor, and control the behaviors of different systems and assets. So that's where we are seeing that. I think you must have heard of smart cities. In Bangalore also, during the first wave and second wave, there was a control room for monitoring pandemic, and basically it is not representing the human beings as a digital twin, but predominantly using the Arogya Setu app for social tracing, for social distancing, etc. I think they have knowingly or unknowingly started using digital twin to actually control, manage, monitor, identify these micros, hotspots, the containment zones, etc. So those are some of the examples where I think people are using in smart city. And if you look at Qatar is one of the countries which has adopted digital twin for their citizens initiative. So basically, as part of their 2025 plan, their focus is the Citizens Happiness Index. So all the amenities provided, like your playground, museums, parking, the parks, the entertainment theaters, etc., all of them are being digitized or twinned, if I might call it, as we speak, to ensure that people come to know whether when that particular the theme zones are open, what is the capacity, how many people have booked, whether there are sufficient spaces, whether a particular show is being cancelled or not. So they'll get all that information. For example, if you're going to schools, what is the subjects or languages taught in that schools? All of that information you can get via this Citizens app. And that's the stage where Qatar is taking the digital twin to, where they're enabling their citizens to actually interact with the smart cities in a digital or a virtual world, right? Some of the use cases, just going through it, I'll just not go through all the use case. I might just share one of the use case, as I think I'll talk about an example of quality management, which we implemented in Kodak film factory. It's a 3-floor factory in Rochester in US. Basically, the challenge we had was every time a film gets manufactured or produced, the thickness of the film is a key parameter, and whenever there is a dust particle or if the thickness of the film varies, the entire film roll had to be discarded. So this was causing a lot of wastages and slippages in the actual deliveries of those committed. These films are used for medical purpose like your X-rays, etc., and hence the quality was very, very crucial. So I think what we did was first we installed a set of sensors, including cameras, to identify and detect the variations in the thickness of the X-ray films beyond the threshold points. And then we also use the camera images to identify and detect any dust or unwanted particles, right? Once these two were done, then now what happens is the control room, the person who's monitoring this will get an alert whenever the thickness variations increases, and he can trigger the chopping of that roll at that point of time. So instead of wasting the entire roll and discarding the entire roll, now what happens is only that portion of the films which has the contaminations or which are defective, only those gets discarded, and the entire rolls, basically the quality. One, we get a consistent quality. Two, the waste is minimized. Three, they were able to deliver to their commitments. So that's one example of where a live case where they have used the digital twin to effectively use. Again, GE is a lot of GE power factories, etc., have also started adopting these use cases to get the operational efficiencies of the products plans in real-time mode, so that they can take corrective actions almost immediately. So that's a few examples where we have used. Now, looking at digital twin, the reason why it has multiple definitions and different people look at it is from a different lens is because of the dimensions, the multiple dimensions it has. I think we'll talk about the first dimension, which is nothing but the hierarchy levels. So the hierarchy level indicates which component or where you are twinning the entire system. Initially, it was mostly at the granular, at the component level, where you get to know, let's say, for example, a light, right? When we're talking about street lights, so it will just tell whether a particular lamp or street pole, the light is on or off. So it is just going to give me information about that particular light, so that I can either initiate a replacement of that light when the light bulbs are fused, right? Now, from the light bulb, it went on to the light pole, right? So basically, if someone has dug a wire and the wire has come out, or the switch to turn on, the turn off the light electric poles, or the solar panel, the charger in the battery life or the battery charge of the solar panels of the street lights, are they sufficient for that duration of time, etc. So now, instead of just looking at the bulb, now it is just going at the component level, right? Let's say it's looking at the electricity power connections to the light. And then after that, we slowly go on to the higher level, which is the entire product, including the street light, the connectivity to the nearest electric poles, etc. And then slowly it went on to include the process, right? So it included the maintenance process, like, for example, Bescom will every 6 months, they will come and monitor, or they will forcefully replace some of the electric lights or some of the connections or switches, etc. And then overall, now it goes at the let's say at a particular part of a district, or at different levels of district. Let's say we are talking about Hebal as one region, right? Sivajinagar as another region. So how do I maintain all the electric poles or electric street lighting systems connected together, right? So that's the different level of hierarchy. So right now, if you look at in 2018 onwards, people have started looking at multi-system. Earlier, it was all restricted to one system because they were focusing on optimizing the entire behavior for a particular systems. Today, with the advancement in AI, analytics, cloud infrastructures, etc., now I'm able to take a multi-system approach where I don't have to restrict it just one system, but then I can manage, I can do a what if scenario analysis, I can do the predictions across multiple systems, right? Now, the second dimensions is what I call as life cycle. Again, like I mentioned earlier, it all started off in the design stage where they want to mimic the actual product in a virtual world during the design and pick what is the best design parameters, like what should be the temperature threshold, what should be the maximum inputs or maximum load for that particular product, etc. So from there onwards, it went on to the actual construction phase or the build phase, where during the build, how do you install it? Is it being maintained correctly? Is there any rough handling, or is there a part which is broken, etc.? Or what is the impact? Let's say if you're transporting a particular equipment from one location to another locations, are there too much of a vibration, which might cause some parts to actually break, or which might cause some parts to actually overheat, etc. So I think that's what slowly it went on to the build phase. I think the other phase where predominantly in the manufacturing world, people have actually started using is in the operate and maintain phase, because it is their day-to-day bread and butter. So to make the life easy for the operate and maintain personnel, the factory floor managers, to ensure that he or she gets the entire insights in one single dashboards, etc. I think the Kanban process also helped basically where to visually showcase if there are any issues, so that any of the plant floor members can basically take corrective actions, etc., to catch the issues early on, right? Basically being proactive rather than reactive, or I think they use the word left shift of quality, etc. So that's where I think even today, if you look at majority of digital twin use cases, it is prominently in the operate and maintain phase of it. I think in the recent past, like I said, in the last 2 years with the advanced AI, machine learning, etc., optimization has become another key focus areas where people are saying that, especially with the net zero commitments from different countries, different industries, etc. They're saying that how can I reduce my energy consumptions, right? Can I reduce my light intensity? Can I reduce my AC flow, the duct flows, the air flows in those AC ducts to optimize or minimize my energy consumptions in real time? So they're taking into account the environmental context, the weathers outside, the illuminations within the buildings, etc., to make those decisions where it will automatically adjust the air duct flow if there is no capacity or there is no occupancy in the office building, right? So I think there are different automations which we have implemented, again working closely with the facilities management systems or the building management system, because there are already these systems which will give me those connectivities and those interaction points. They have been able to connect the twin to the take the operate and maintain aspects of it to the next level. So we have seen with implementations of twin, we have seen nearly 20% reductions in the electricity bills, right? Just by optimizing these, monitoring these presence of the capacity of people present in that particular locations, managing the air duct flow, and basically using the window binders to ensure that you don't have to turn on lights, etc. So if you can just optimize it, we have few standard algorithms which has been developed over the past couple of years to optimize and minimize your energy bill. Of late, again, as I said, nuclear has found a very good use of digital twin, and especially with most of the nuclear reactors, especially in the European region, being decommissioned because of the age of those nuclear plant reactors. We have seen a lot of use cases of digital twin in decommissioning because of the radiation levels which will be there in those nuclear plants. So typically what they use is they use robotic bots to actually physically go there and basically decommission, dismantle the components, categorize them into high radiation, medium, low radiations. I think there are 7 levels of categories, packaging them and ensuring that they just get to the destruction zones in the appropriate levels of classifications. Right. So that's again where we are seeing increased integrations right from design to decommission phase, where digital twin is ensuring that the same design information gets shared to the construction phase, then gets moved to operate and maintain. They don't have to recreate their own twins for operate, or they don't have to create a twin for their own build or design. So earlier what was happening is they used to have these siloed versions of twins for a design for simulation purpose, or twin for operate and maintain purpose, etc. So now we are seeing a integrated lifecycle approach by using the twins, right? Again, the use cases are many, depending on the industry you're working, depending on the type of the ecosystem player you are, whether you're an OEM, whether you are a service provider, whether you're actual construction engineers, etc. You will have different use cases. I think right now, most of us are still in the historical information use cases, where we are still evaluating the historical informations. People are predicting, they're using AI, ML, stochastic models to predict the future state. But I think the future state prediction is at most for maximum of 1 week is what I have seen, or 1 day sometimes, or 4 hours, etc. But I think long-term trending is still being evolved at. But right now, at least the predictions are just restricted to about a week's time, where they're taking the data, historical data, and applying few models and algorithms and predicting at least what will happen in the next 7 days. They could also do it at an hour by hour, what the variations or changes is which takes place. Again, if you look at the twin, we can classify into different types of twin. The easiest, and usually when anyone adopts or wants to implement a digital twin, we would suggest to go in this order, so that they will be able to understand and see how twin is benefiting them. So the first one is status twin. I think it is just trying to see if a particular system or a component or a process is broken. So basically, again, it helps them to take reactive decisions promptly, right? So rather than getting saying that, okay, a particular, let's say for the streetlight example, a particular streetlight has broken, instead of coming to know about it after 7 days of the light actually being broken, today you can get to know that the streetlight is broken immediately on an hour basis when it is broken. The next evolution is the operational twin. I think in the manufacturing world, all of us must be familiar with the OEE, basically efficiency, effectiveness, measurement metrics or KPIs, which are standard in any manufacturing industry. So when you're looking at the operational aspects of the twin, you want to know what the health of that particular system is, or particular process is, if there are any latencies, whether there are any deviations, etc. So basically focused around the quality and the efficiencies and effectiveness of a particular product. So that's the next stage, where what you do is you capture the raw informations. Based on it, you say whether it is functioning, it is not functioning appropriately based on the capacity you have actually constructed for, right? So is it working normally, or whether there is lower workloads, or whether there are very higher workloads, etc. You can just look at. Once you have that parameter, next stage would be to actually do the simulations. So you can then say that, okay, what happens if I increase my utilizations of this particular set of system or assets? Will it break? Will it impact my product lifetime, or will it result in higher net zero or carbon emissions, etc. So there are multiple parameters. So you do a what-if scenario analysis in the simulation twin, and then you feed it back to your operational threshold. So basically, once you say that, okay, this is an best optimal parameters based on the current operational status, or the current operational inputs, then you pick the best and then you optimize your operations so that it suits your workloads or it suits your environmental conditions more accurately. The next, or the nirvana state for any twin would be the cognitive twin. Here, like I said, if you're talking about smart buildings, right? As I mentioned, instead of allowing humans to instead of alerting to the humans to say, okay, now reduce the air duct airflow in a particular air duct. Now what the twin themselves can make those decisions, right, within a particular parameter or threshold. If the decision is within a particular acceptable level of thresholds, then the twin itself can create an audit trail and then act on it, saying that, okay, these are the inputs and these are the reasons why I'm making this decision, and it can reduce the AC duct flow, etc. At least in the non-critical systems, we are seeing people being open to experiment. Right now, I think there are a few proof of concepts being undertaken in this world. As I think what we are calling it as a cognitive twin, where basically the twin itself is self-healing or self-acting based on the context or environmental parameters, right? I think I spoke about the maturity model. I think the types of twin also helps you to move the maturity from level 0 to level 4. As I mentioned, level 4 is all about the predictive, the feedback loops, the self-healing mechanisms. Level 3 of maturity is basically you can track, you can know whether your asset is broken, or you can predict at least in the next 5 days in advance, or 5 hours in advance, saying that there is going to be a potential failure. That's the level 3. In level 2, basically, at least you know that your systems are performing below the threshold parameters or above the threshold parameters, or there is scope for efficiency improvements, etc. In level 1, it is more about basically helping you to simulate, helping you to identify and design your parameters so that you can optimally utilize your systems or assets in place. Level 0 is basically it's more the informational twin, where you just know whether a particular equipment is working or not, right? Now, a typical workflow, I think, as I mentioned earlier, what does a digital model mean, right? Digital model means multiple things. Like, as I said, you have the physical model. When you say the physical model, it will be different for different systems. So it will mimic the physical characteristics of the product or the systems, right? The geometrical model basically will tell you the sizes, the dimensionalities of that physical model. So the impact, so you bring in the dimensionalities, the contextual environment, etc. Your rule model is basically the traditional way, where you say that these equipments or these systems are to be worked in a particular threshold conditions. So you quantify those thresholds. You say that they need to work on this in this scenarios, and they should not be functioning in these scenarios. So all of those rules, what you can codify. The behavioral model is basically as I said, the cognitive aspects comes in the behavioral model. If there is a increase in the temperature of the environment, right, or if there is too much rain, can I reduce my AC duct flow, etc. I think those are your behavioral. Or if there are the capacity or the number of people in a particular building is reduced to 3 or 2, what should I do? So basically those self-healing characteristics, behaviors would be modeled using the behavior. And as I said, once you have defined your twin model, what you do is you create an instance of that model, and then you say that for every instance, these are the behavior, or you define your threshold parameters for that instance based on the conditions. And then you continuously keep track of the feedback or the parameters or the sensor inputs you keep getting from these actual physical devices. And then you run your algorithms, and basically you get and you take your corrective actions or the feedbacks which comes back, and then either your algorithms is self-healing, so it acts on it, or at periodically you can review your physical model, geometric model, rule model, or behavioral model, and take the appropriate actions, right? So on the right hand side, you will see the actual implementations. I think the sensors or the IoT technology has enabled the adoption of digital twin, and cloud has taken it to the next level by providing the resources for analytics, predictions, simulations, scenario plannings, etc. So today, if you look at it, most of the industries, as I showed earlier, I think most of them have already implemented or currently implementing the condition monitoring aspects of it. The simulations typically has still been restricted to the design world. Today, people are trying to extend this to the operate and maintain world, where they're trying to see if I can reduce my parameters based on the actual behaviors of the systems or the usage of the systems. How can I optimize and what will be the impact, etc. I think the focus now, I think in the next 2 years, would be around the functional simulations. I think in the short term, the predictive maintenance, basically trying to say that, okay, this is going to fail. So even before you actually it fails, you are actually shipped your inventory. So for example, I think we'll talk about in one of the highways in Andhra Pradesh, where we had implemented this for the highways maintenance, right? So especially what happens, whether it is street light or the potholes or the vegetations which comes on the highways, etc. So there are a lot of issues. So what we did, I'll just give you an example of the street light. So typically, street light, when it is broken, it's very costly for us to ship one street light, the bulb, to a particular vendor who will go and then fix that particular street light. So instead, what we do is the moment we predict that there is going to be X number of street lights bulbs going to be fused, we ship that inventory, plus we have some formulas where we say, okay, 10 or 100 street lights will be given to vendor A. So whenever there is a break, then we can they already have the inventory, they're on the ground, they'll just go and fix that electric light, so that we meet the SLAs. So that's another example where we have actually used predictive maintenance for optimizing or minimizing any events. Dynamic scheduling, I think if you look at, if some of you are from the asset management world, if you look at the maintenance of these systems, so typically they say that let's take your car itself, right? When you buy a new car, they will say that every 6 months or every 10,000 kilometers, etc., you need to do a service, right? So that's it's a pre-scheduled or predefined event. Now, what will happen? Let's say there are sensors, there is intelligence in your car, and it tells that, okay, I'm going to fail, or I have used this particular system much more than what was I originally planned. So, and hence I need to replace the systems. Let's say the brakes, for example, and my brakes have worn out, so I need to replace the brakes in the next 2 months, so that I can avoid any accidents. So instead of going every 6 months and just generally blindly changing the brakes, you actually get the information status of the brake, and then you say, okay, this time when I'm going to doing a service in the next 1 or 2 months, I need to fix my brakes, etc. So I think these are what we are doing in the dynamic scheduling. and we are applying the intelligence there to make out or provide the informations which is required. Like I said, the different technologies which has enabled us with digital twin. I'll talk about few. I think IoT, which basically is dependent on the connectivity with 4G, 5G, etc. With cloud, it has given me the power. With sensors, it has given me the capability to capture the state or health of the systems. And virtual reality is something which people are adopting. So basically, the biggest challenge has been the field visits, because every time you do a visit, especially let's take an example, if you're talking about railways, right? If you want to see if the railway track has a crack, etc., it is you need to stop, you need to plan for it so that you divert your trains, your tracks are free, etc., and then you start doing it. And especially you need to plan, you need to send some engineers, the signaling engineers. There are different disciplines within the railway lines to the field to do that evaluations. Today, with augmented reality, virtual reality, and the networking, the 5G, 4G networks, different disciplines can sit in the corporate office. The field engineer can go there. He can actually show virtually. They can collaborate virtually, and they can resolve, or identify the problems, etc. So that's another use case where we have we have implemented, or at least we are experimenting the collaborative use of virtual augmented realities on the use. As I said, we are seeing lot more algorithms being developed by different players, different industries, the manufacturers, the designers, the constructors, etc. So the future, what we foresee is basically an algorithm economy where for different systems or different components of the systems, you will have different algorithms for whether defining the rules, or whether you're defining the behaviors, or whether you're defining the physical characteristics, etc. So that's where in the near future, we will all be talking about who's going to provide the algorithms or the systems integrations between these algorithms, so that you can create that hierarchical level of information which is required. Right. Again, analytics is going to play a key role with real-time data, advanced analytics, decision making, and now, as I said, the self-healing aspect is becoming more and more being adopted or being evaluated as we speak, because now based on within the given threshold, if a decision falls within a given threshold, then the systems itself can initiate the action. So actionable insights, the algorithms to generate and produce actionable insights is becoming very key. Right. I think, again, if you look at the digital twin from an analytics lens, I think it started off with the rule or logic-based mechanism. So people will say, okay, if this happens, then do this, or this happens, do this. Then people have started using machine learning to identify what the parameters, the thresholds are, rather than just looking at the numeric values. So they're looking at basically learning based on what humans have been doing, and then basically they can mimic the human interventions, identify the human interventions, and notify whenever a particular human interventions are required. NLP, or natural language processing, is to ensure that the definition or the semantics of the data we used in digital twin are uniform, because there will be different vendors. Different vendors will use different terminologies or different behavioral characteristic descriptions, etc. So how do you ensure that it is common or it's being used in the right way? Earlier, it was all about statistical modeling, but these days people have moved to deep learning, and they're using images, more and more image analytics to make predictive decisions. In a nutshell, the way you go about implementing a digital twin is basically you first identify your requirements, you discover your use cases, and the people who are going to be involved in using your digital twin. Then you identify what type of data, what is the sources of the data, the context of the data. You talk about the physical attributes, the behavioral attributes, the rules, the business rules, etc. And then you create your intelligence. So today we are seeing the use of ontology and knowledge graph or the graph database as one of the key aspects being evolved in digital twin, where most of the time when you're talking about systems or hierarchies, it's all about relationships and associations. So that's what is being represented in knowledge graphs. There are standards coming out on ontologies for different systems, whether it is for buildings, whether it is for railway systems, etc. And then you are then presented your decisions or intelligence to the users so that they can act on it. So I have few demos, so I'll just straight away go into this demo. So this is a digital twin where this showcases where initially we had the 2D drawings or the CAD drawings in paper. So we had tough time getting a digital twin. So the first step is to digitize this, basically convert this 2D drawing into a digital world. Basically, this is a highway bridge in England where we got all the drawings. It was very old drawings. So what we did was we got a scanned copy of these drawings. We then converted into a 3D BIM model using the CAD/CAM, the Autodesk tools. And then basically simulated the different parameters, the physical characteristics. In this case, you can see that we are simulating the constructions of the highway bridge. How to lay it, means what should be constructed first, the sequencing of the actual constructions of the bridge, identifying the different components, the interactions between these components, how it behaves, and if I change or if the stress of one of the pillars are weak, etc., what will be the impact? So basically, I can do different what if simulations, parameters, what type of materials should I use? All of those I can take the decisions. And since this is already a built existing bridge, then in that case, how can I re-strengthen a few of the pillars or few areas to improve my longevity of this bridge so that there are no accidents, etc. So basically integrating taking the physical drawings, converting into a virtual 3D drawings, and then I was working together to identify which elements, what decisions, what corrective actions, maintenance regime I need to basically undertake and perform. So this is an example where you can digital. So this example showcases the digitization, especially in the design phase or basically when you are revisiting or you want to undertake a repair of this particular bridge to identify which areas you need to focus on, and basically what should be the key elements or components which we need to basically look at. So I'll just fast forward a few areas. So you can click at each individual element, understand what the characteristics of that elements are, so that your decisions, your design decisions or reinforcement decisions can be made based on the current conditions, etc. So this is one example. So if I look at it, this was another example. I talked about collaborative using the augmented reality or virtual reality. So basically, this was a design where the teams from different regions were involved. So this is an example of a digital review where they want to, again, this is for an highway where they're constructing an highway bridge. And the challenge was without impacting the associated buildings nearby. The area for bringing in the cranes or for bringing in these heavy equipment, finished models were very limited. The space was very limited. So basically here the people who have visited the site, etc., were interacting with the people here from Bangalore, where they look at what will be the impact, what is in which order, if they have to move a particular a module in that space, whether they have space for storing those modules, etc. So this enabled them to ensure that their constructions doesn't get impacted because of the wrong decisions. Let's say they didn't have an inventory space to keep some of the modules which were built at the site, so they had to delay it being transported there, or whether those modules need to be in a particular shape so that it can be transported and it can be placed at that particular locations. So this is another example where they did the collaborative. They used VR devices to collaboratively review, interact, communicate different parts of things. This is another tool which was developed. I'll just jump into the, this is about looking at, this is for one of the airports, one of the most popular airports, where we wanted to know which terminal highways where the assets are not functioning well. So here the air condition in that particular airport was very, very critical, or considered critical. So what type of interventions they need to do to ensure that the AC services at level 4. So what interventions? So we could actually do a predictions 30 years in advance for a particular systems, etc. using this. So this is a predictive simulation model which was developed. So this is all about artificial, the computer vision piece, where the cameras are mounted on railways. And we are whatever the images which are captured by the railways, we are able to identify whether there is a signaling post which is missing, or whether any particular asset has been malfunctioning, etc. So we are able to not only track the assets, because the theft of these railway track assets are very, very high. So one, to identify if those assets are there or not there, and two, the conditions of the assets based on basically whether it's broken or some dangling points, etc. are there. So that's at a nutshell which I wanted to cover. Any questions, comments? Open for any questions and comments.
So the first question from my side, I made a note of my question and keep on postponing as you are progressing with your presentation, Santosh Kumar. Santosh. So you mentioned something about Kodak film manufacturing use case. So where there was some thought of A and ML also you touched upon at that point of time. Which is very difficult kind of thing I understood from your this one. What was the so what kind of AML they considered versus it is delay kind of thing, hours, days kind of thing it will take kind of thing. So can you little elaborate that particular area of what exactly?
Sure. I think a very good question, Jagan sir. Basically, if you look at the reason why I explained the Kodak factory was the decision needs to be almost instantaneous. And when I say instantaneous, within a few minutes rather than hours or days, right? Because if I don't identify the area where there is dirt or the thickness of the film is high, then the longer I delay the identifications, the longer my role will get wasted, right? Because I have to chop off that area and then destroy that particular section of the films produced. So what we did was basically in the vision part of it, we have used the RCNN algorithm. Again, it was a powerful computer which we used, and we were able to achieve the decisions in less than 30 seconds in the RCNN algorithm. Of course, when it comes back to the user, etc., it takes about few minutes. So I think it's a max of 5 minutes is what we have said. The role will get wasted a maximum of 5 minutes by the time the operator initiates a cut and then discards that and then reinitiates a start. So that's what we were able to do for measuring the thickness, because see, the dirt was okay, because sometimes once it gets into an X-ray film, the medical doctors can discard if they feel that the film is not correct, etc. But the thickness was very essential. So basically, what we did was we installed a special equipments which measures the thickness or identifies the thickness. And the moment, again, we wrote our own statistical, it's all stochastic probabilistic models which we implemented there, and thickness will come in few seconds, and anyway the feedback loop to the operators they'll get alerted in less than a minute. That's what we had identified for the thickness part of it. Hope
Thank
that
you, sir. Thank you. Thank you. But I thought of asking something on the construction one, but the bridge example demo that you have mentioned, I think it is relevant there basically. So
that's correct.
while design and all, these civil engineers and all, they normally use ANSYS, ProE, or these kind of tools to analyze the strength or maybe structure of it and the overall structure of it. So, what kind of tools or technologies they used in this scenario example that you have mentioned?
So yes, so basically, again, probably if I just take one step back, very good question in terms of the tools. So here, like you rightly said, the civil engineers, the environmental engineers, the structural engineers, etc., would have their own tools like your microstations, Bentleys of the world, Autodesks of the world for doing the simulations of these the stress, doing the stress analysis, doing the FME analysis, etc. Uh, the digital twin idea is not to replace those tools or become a master tool, right? Rather to take the inputs or the outputs generated from these tools and then model them, right? So you still do your analysis, you still do your evaluations using the tools which you're comfortable with respect to your decisions, with respect to your disciplines. But then the output of it or the results or your evaluations, different parameters, right? Again, the integration of that was a big challenge and it's still a big challenge. Like different tools will have different definitions, the semantics of the terminologies they use, etc. So that's where the data dictionary becomes very, very key. So to answer specifically to your questions, like you rightly said, I think microstations is what they use. They use EnergySys for IES for energy analysis. For structural analysis, they use the FMEA. I think there are different disciplines uses different tools of it. It's endless tools. But what Twin does is basically the outputs or standardize or integrating all of these different disciplines so that the interdisciplinary communications and collaborations becomes much more effective.
Thank you, Santosh. So one more final question I can't resist asking. You introduced this new area kind of thing I foresee, but I don't know. So AML, see in the kind of complex scenarios what you have showcased, right? There are multiple processes or multiple areas where it attracts or warrants AML kind of algorithms and everything. But finally, somewhere these are all fed by some properties or some kind of data, right? So that is fine. Each individual area, it may perfectly, it will work well. But you introduce, I don't know, there is a how this orchestration of these kind of these silos of or different adoptions, different places, right? How this orchestration is it a challenge? Any comments from your side?
Yes, I think absolutely. Today we are struggling exactly in that area. Like I think in the previous question also you mentioned, right? Different disciplines will have different tools which are very specialist for their functions or for their analysis or for their simulations, right? Now, just making the environmental engineer communicate to a civil engineer or an electrical engineer or mechanical engineer communicate with the structural engineers, etc., is going to become very challenging. So that is where the ontology or the knowledge graphs becomes very, very key. And today, if you look at it, it is in a very nascent stage, and especially in the AEC industry or the construction industry. Right now, our organization is focusing on building the ontologies or the knowledge graphs of the different systems so that it, at an individual level, at an individual component level, there are algorithms or mechanisms or formulas in place. But then we are talking at a system level, we are talking at integrating the process aspects into the system, etc. And that's becoming a challenge and it will evolve. Right now, that's where the entire industry is focusing on, Jagan sir.
Thank you. So that is the area of this one active research and for industry as well. So there is a question from Madam Uma, Dr. Uma Madam. Is there any relation between TinyML and twin technology? You may take that question.
So twin technology uses ML and TinyML is one aspect of it, right? So basically, I think you're talking about edge ML because if you look at when you're talking about twin doesn't mean everything resides on the cloud, because sometimes you may not have the luxury of you might want to make decisions, especially if you're on the plant floors. For example, in a power station in Hong Kong, though we had a powerful cloud process, everything built. But then when the electricity breaks down or the power plant breaks down, they have to bring that up quickly. So hence they needed an edge ML, if I might call the TinyML. I think that's what gets deployed in the edge systems, so that it provides intelligence to the people on the floor to make short-term decisions or immediate decisions, while the cloud provides the long-term, the simulations, etc., or the more advanced intelligence there. So the relation is basically twin uses TinyML and different MLs. Hope that answers.
Yeah, thank you, sir. Thank you.
The next question, if I can read, what tools are available for engineers to create digital twin of existing or proposed production systems? So I think, again, a very interesting and a good question. Today, if you look at it, there is no one single digital twin tool or technology or system. It is evolving. There is competitions. In fact, what we had done was we evaluated 40 plus different technologies and tools. Each of them have their own specializations or have their own advantages and disadvantages. And basically, there's no one size fit all approach there. So based on the use cases, we have to look at what tools or what technologies to use. And that's one of the service which we started offering early this year, and we have been working with multiple customers on that. So unfortunately, there is no one size fit all solutions for digital twin as of now. Hope that answers the question. Next question is security of data. Yes, I think that's a big challenge, and that's where the adoption of twin in this traditional industry is being very, very slow. But of course, the pandemic has helped us increase the adoption or the pace of investment in digital twin drastically. But security is a big challenge. Not only security, the high availability, right? Because there are threats from unwanted players where they can just bring the entire power grid to a halt, etc. So you have to be cautious. Of course, there are different security evaluations. There is a cybersecurity separate aspect within the digital twin, which focuses on the security, both internal and external security. The second aspect, along with security, I would say, is the high availability, right? Given that we are all talking about the virtual world, how closely it mimics, it is the visible to make decisions. Irrespective of where in the field or whether I am in a disconnected locations where I don't have internet, etc. So that's another challenge. So high availability and security is a big considerations, and there are specialists or there are separate teams that will focus around this. And today, if you look at, given the adoption of cloud and the expertise we have in these, the industry has built on the cybersecurity space. I think we have crossed the basic minimum threshold, but security is an ongoing discovery process. So I think that will continue to remain a focus area when you're implementing the digital twin. Hope that answers your question.
So thanks. Okay. So we are on top of hour, and we are spent 1 hour on this session. Maybe with that question, shall we wind up conclude, Madam Sujata, Madam?
Yes, sir.
Yeah.
Thank you, sir. The session was very informative. And in fact, I have one question, sir. Regarding computer vision, you mentioned about like prediction. So is there any implementation tools available with respect to this digital twin, sir?
Uh, So when you talk about with respect to digital twin, it is all about using the videos or images to make decisions. It is a mature area, and it is also research is also ongoing and continuing. For example, if you look at traffic analysis, number plate reading is another good example where I think even in Bangalore or almost every country has the number plate readings where they're able to take a photograph of the cameras coming in either via toll gates or any other junctions or intersections, and then run different algorithms to identify the digits and characters. I think the most popular tools or technologies in computer vision is TensorFlow. I think that there are different algorithms, RCNN, GAN, etc., which is evolving and which is continuing to evolve. So these are the current most popular ones. Of course, these days the speed and the compute power is becoming a big question. So these algorithms have evolved into, I think, compared to the earlier questions, the tiny MLs, which can be run on your mobile phone or on embedded devices, which doesn't have very high compute. So answer is yes, madam.
Yes.
Basically, it's an evolving thing, and there's no standard, but it depends on the use case again. But TensorFlow is one technology for us to look out for, especially if you're interested in computer vision.
Yes. Thank you very much, sir. Now we have come to the end of this webinar. So I request Dr. Uma Maheshwari, madam, to propose vote of thanks.
Thank you, ma'am. Hi, everyone. I am Dr. Uma Maheshwari, and I am here to present the vote of thanks for today's webinar. I would like to thank Mr. Santosh for accepting and enlightening us with his knowledge. Today's webinar is full of knowledge and very, very informative, and it gave deep insights into the topic. The application of twin technology, especially and demonstration, what you have shown was really informative. Once again, I would like to thank Mr. Santosh for taking out time from his busy schedule and enlightening us with the knowledge. Thank you so much. I would also like to thank Dr. Param, Chair, IEEE ITS, and Dr. Amber, Secretary, IEEE ITS, and all executive members of ITS chapter for organizing such a wonderful event. Also, I thank all faculty and students of various institutions and researchers for paying your attention and learning. So I end my speech here. Thank you so much.
Thank you, madam.
Can we request one photograph
Yeah,
from Santosh sir
I
and
request all the participants and Santosh sir, come switch on your videos.
can you please stop sharing the your presentation so that we can have in one grid all photograph at this point of time? Mr. Santosh, if you are listening, yes. Thank you. I request all, please turn on your video. Thank you.
Yeah, I request all the participants to fill the feedback link. Feedback link is being shared in the chat window.
Once again, thanks, Santosh Ji.
Thank you, Jagan sir, and thank you IEEE for having me on this for this tech talk. Thank you.
Thank you,
Thank
sir.
you, sir.
Thank you so much. Thank you very
Thank
much,
you.
Mr. Santosh, for accepting our invite.
Sir, can you give your ID, sir? Email ID?
Sure, madam. I can just.
Yeah, got it. Thank you.
Okay. Thank you all. Have a good weekend. Bye.
Thank you. Bye.
Thank you, everyone. So I'm just disconnecting. I hope everyone downloaded your
Yeah.
certificates.
Thank you, sir. Thank you, Dr. Humber.
Thank you, everyone. Thank you.
Sujata. Yeah.
Thank you, sir.
Yeah, thank you.